So in factoring expressions 2, we are going to be working with perfect cubes. This is what we will refer to. And this is the general template. Press pause if you are rewatching this. The general template that we are going to break down the expression we're given. We'll take one term from the front, one term from the back. Then we'll take two terms from the front, two terms from the back. We'll achieve this term by multiplying the first two terms. And then we'll use the given operation, opposite of given operation, and this will always be positive. That seems like nonsense, but let's apply it here. Are you ready? Let's look at example number 1. When you do not see a number in front of a variable, it is a hidden 1. So please put a 1 in front of the A. Now this is showing work. This is what I want to see. So I want to break down the 1. 1 breaks down to 1 times 1 times 1 3 times. So let's break this down. 1 times 1 times 1. 27 breaks down to 3 times 3 times 3. This is showing your work. Please circle the variable that's on the A. And in our last lesson, we were working with squares, difference of squares. Above this, I would like you to write sum, anywhere you have room here, sum or difference of cubes. That is our lesson. Sum or difference of cubes. And in this lesson, we are able to factor things regardless if it's adding or subtracting. That is not a determining factor whether we can move forward with factoring. Okay, but we are working with cubes, so I'm going to take this number, and if I can divide it by 3 and get a nice answer, we'll move forward. I know 3 divided by 3 is 1, so A. That's the hardest part of this. Can I break down each one of those? If I can move forward. Okay, let's write down the template. This is the template. 3 terms in the back, and we have 2 terms in the front every single time. Okay, so I'm going to zoom out here so I can show you what this means. As a reminder, this last symbol will always be positive, so please put a positive symbol in place. The first symbol says it comes from the given operation. Well, let's look at the operation. This operation is subtracting. The next operation says it's opposite of the given operation. That means these two are always opposite of each other. So if I start with subtraction, the next one has to be addition. Okay, go back and look at the template one more time. Underneath the first 2 parts, it says 1 item from the front and 1 item from the back. 1 item from the front, 1 item from the back. So this is the front. Anything in front of the symbol, subtraction in this case, is the front. So I'm going to take 1 item from each of these categories. So I'll take 1, 1, and 1A. And now I've used them, I'm going to cross it out. Take 1 item from the back. Okay, well in this case, behind the symbol subtraction are my 3's. So I'll use 1, 3, and I'll cross it out. All right, now I'm going to go to this next spot. This next spot, we're going to use the last 2 remaining front items. Okay, well the items in front are 1's and A's, and we have to multiply them. 1 times 1 is 1, and I have 2 A's. And now in back, I'm going to use the 2 remaining items in back, and I have to multiply them. I've used the 1's and A's. 3 times 3 is 9. So before I do this last term, and then I'm done, I have to go, okay, the 1's and the A's have to go in the front of every parenthesis. The 3's have to go in back, and this is still a 3 because it's 3 times 3. Now how do I achieve this term? It said I'm going to multiply the first 2 terms. These are the first 2 terms. We don't have to worry about a symbol. We've already decided we need to put a plus sign here. So when I multiply, 1 times 3 is 3, and there is an A. This problem is done. We're going to go on to example number 2 next. Please find example number 2. we are referring to what's right above. It is the perfect cubes. Is 152 on that list? Is 1 on the list? Can I divide the exponent 3 by 3? Yeah. And why am I dividing by 3? Because cubes are to the third. Okay, so I'm going to show my work here. 152 is the same, 512 is the same as 8 times 8 times 8. And 1 is the same as 1 times 1 times 1. And if I take this exponent and divide it by 3, so if I split up 3 into 3 equal parts, I get b to the first, b to the first, and b to the first. What do I do next? I always make 2 parentheses. There's always going to be 2 terms in the first and 3 terms in the second. What is always going to be the very last one? Always, always, always will be addition. This symbol, whether it's addition or subtraction, comes from the given operation. So it starts with addition, I put addition here. But the next operation has to be opposite of the first. Again, this is always positive. Whatever symbol I'm given goes here, opposite will be subtraction. Now, this is the front. So in front I have 8s and b's. I'm going to take 1 8 and 1 b and then cross it out. In backs, I have 1s. I'll put a 1 and I'll cross it out. So I take 1 from the front and 1 from the back. In the front of the second, I'm going to take 2 from the front. So 8 times 8 is 64, and there's 2 b's. 1 times 1 is 1. Now, what do I do about this middle term? I'm going to multiply the 2 front terms. 1 times 8 is 8. We don't have to worry about the symbol. 1 times 8 is 8 with a b. I would like you to go down to example F. Please go down to example F, and we're going to rewrite this example. Example 5. I want you to rewrite example 5 by making that square into a cube. So first I'm going to break 8 into 2 times 2 times 2. Remember that. Okay, F to the third breaks into, divide this by 3, F to the first. 125 breaks into 5, 5, and 5. You don't have to memorize this. You can come right here, find 8. 2, 2, 2, find 125, 5, 5, 5. This is always a positive. Since this problem is negative, the given operation is negative, it goes into the first place, and this has to be opposite. I'm going to take one item from the front, which is a 2 and an F. Take one item from the back, which is a 5. Now in this place, I need to take the remaining items from the front. 2 times 2 is 4, and there's 2 F's. 5 times 5 is not 10, it is 25. What goes into the front? We're going to multiply these 2 terms. Don't worry about the symbol. 2 times 5 is 10, and don't forget about the F. You are looking at this. So as a reminder, this little pink piece of paper, this only applies to squares, and we're working on cubes. So this should be upside down so you're not confused. Is 64 on this list? It is. Is 216 on this list? It is. So I want to see you show your work. 4, 4, 4. C, 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 because I'm breaking this into 3 parts. And 6, 6, 6. This is always addition. For this problem, I'm given subtraction, and this is the opposite of subtraction. In this first place, I'm going to take one item from the front. So these are the fronts. I take one item from the front, a 4 and a C. And I take one item from the back, and then I cross out that. This is showing your work. That's showing me you didn't just copy from somebody. You're understanding how it breaks down. Now from over here, I'm going to take the remaining pieces from the front. 2 4s multiplied to give you 16. 2 6s multiplied to give you 36. To receive this middle term, don't worry about the symbol. We're going to multiply. 4 times 6 is 24, and there's your C. But there's a problem. This problem is different than the other 3 that we have done thus far. When I look at 4 and 6, I recognize that there's a number I can divide out. What is the largest number I can divide nicely out of 4 and nicely out of 6? So put a 2 up front. 4 divided by 2 is 2. 6 divided by 2 is 3. Whenever you can divide something out of the first parentheses, when we're factoring sum and difference of cubes, you're going to be able to divide something out of the back. Now, do you have to choose the largest number? You do. So I had students in my previous hours that said you can divide by 2. That's not wrong, but it's not the largest number. So you either use your calculator or use your number sense. What's the largest number you can divide out? It is 4. 16 divided by 4 is 4. 24 divided by 4 is 6. And 36 divided by 4 is 9. We have one step left, and that's just to combine what's not in parentheses by multiplying. 2 times 4 is 8, and this is my final answer. I would like you to look right now, and we're going to try one problem before you try a practice quiz problem. With your partner, you have 2 minutes or less to do problem 14. I'm going to give you a head start. Ready? Oh, I said number 4. My fault. Number 4. And begin. I look at my sheet. I find 343, which is right here, breaks into 7s. I find 27. 27 breaks into 3s. And D breaks into D. Okay, so 2 in the first part and 3 in the second. This is always positive, positive, and negative. Remember, with sum and difference of cubes, you can have a plus or a minus in the middle. So 7 comes from the front, it remains in front. 3D comes from the back, it remains in back. Now in this position, 7 times 7 is 49, and 3 times 3 is 9D squared. Now what goes right here? 21D. So here's the first example that's not on your paper, and you're going to see that 24 is not on this list and 375 is not on this list. So what you're going to do is you're going to locate where 24 would be on the group here. So if this was a list of numbers, where do you find 24? And 24 would be in between 8 and 27. So you locate where this smaller number would be. It's right here, and we're going to work ourselves down. Knowing that dividing by 1 is not going to simplify anything. So I only have one number before I get down to 1. This again would be where 24 is. Don't talk when I'm talking. This is where 24 is. 24 divided by 8 gives me 3. I want to know if I divide this number by 3, would it also come up with a number that's on this list? So I'm going to come back here and I'm going to go 375 divided by 3. Okay, that gives me a number on the list. It's 125. 24 divided by 3 also gives me a number on the list. It's 8. So if I divide both of these terms or factor out of 3, I'm then able to do a problem that allows me to use the sum or difference of cubes. So doing this problem, what does 8 break into? Please look at your list. Go. What does 8 break into? So 2. What does 125 break into? 5. 2 times 2 is 4. Oop, I don't need an x there. 5 times 5 is 25x squared. This would be addition, and it multiplies to give you 10x. Let's look over here. I don't see 1024 or 2,662 on the list. So I find 1024. 1024 is right here. And I start just dividing until I find one that works. So 1024 divided by 1,000, it has to give you a nice, 1024 divided by 1,000 has to give me a nice whole number. If it doesn't, I just continue to divide by each of the perfect cubes. It doesn't work. 1024 divided by 512. And I'm just going to go all the way down the list until I see is it possible to get one that gives me a whole number. When you reach a whole number, this whole number tells you the number that you need to try to factor out. So I'm going to put a 2 out front, and let's see if this works. 1024 divided by 2 is 512. Is 512 on the list? Okay. Take 2,662 divided by 2. Is 1,331 on the list? So if I'm going to break this apart, 512 breaks into 8, 8, and 8. I can do that. 1,331 breaks into 11s. What does this break into? Tell your partner, what does this part break into? Y squared, y squared, and y squared. Because 6 divided by 3 is 2, and I can move forward with this problem. You got to know that to do this problem. Let's jump back to number 6 now. So in number 6, I see 32. The first thing I do is I look here, I'm like, there's no 32s. What am I going to do? So when your number is not on the list, I find where that is. Here's 32, and I'm going to work backwards. I'm going to work down. So I take 32, and I divide it by 27. We don't get a whole number. Okay, got it. Then I take 32 and divide it by 8. It works. If it works, this is the number I'm going to try to factor out. So for this problem, I'm going to try to factor out a 4. 32 divided by 4 is 8. 108 divided by 4, 108 divided by 4 is 27. Working with your partner, this is showing work what I'm doing right now. Working with your partner, you have 1 minute working together to finish this problem. Ready, get set, and begin. Talking together. What is the answer? Work together. You're picking up a pen or pencil and you're working through this. I'm going to factor out a -2 in example number 7. So if I take -2 and divide it by -2 and I get a 1, awesome, because 1 is on the perfect cube list. I can divide this number by 3, great. It doesn't matter if it's addition or subtraction. When I take 75 and divide it by -2, I end up with a -75. Now, in order for us to continue to factor, here's what needs to happen. It does not matter if this is addition or subtraction, but there are 3 things that have to happen. This has to be broken down by a perfect cube. 1 is a perfect cube. We're good. This has to be divisible by 3 because we're working with cubes. That's great. Is 75 on this list? You can't go any further. This is as far as you can go. Please flip to the... You talk your way through this as I'm doing this, please. I want to show you that before you start talking, I want to show you that j to the 4th means j times j times j. Okay, you're going to start talking right now. Ready, go. Yep. Okay, so how do we do this? The first thing I see is I have variables that are the exact same type. One's not like an X and one's a Y. They're exactly this type. So there's 1j here and there's 4j's here. What's the most j's I can take out of both the front and the back? 1j. Now I know that 3 is not a perfect cube. And so I know that if I take 3 and divide it by 3, I get 1, and 1 is a perfect cube. So I tested, I take 2187, I divide it by 3, and I realize, hey, 729 is also a perfect cube. So the first thing I do is I realize I can factor out a 3 out of both of these, and I can take a maximum of 1j. 3 divided by 3 is 1, and I've already taken out the j. 2187 divided by 3 is 729, and I've taken 1j out, leaving 3 j's remaining. So now I look at my list. 1 breaks into 111, 729 breaks into 999, j to the third divided by 3 is j. So from the front, we keep the same symbol, has to be the opposite of the original, and this is always positive. I take one item from the front and one item from the back. Then the remaining ones, when I multiply them, 1 times 1 is 1. The remaining 9s, when I multiply, is 81j squared. And how do I get this middle term? I just multiply this, 9j. So if I'm going to do this and slow this problem down, I have 5k subtract 320, and there's 4k's here. I can see that I can take a k out of both the front and the back, so I know I can factor out a k. Is there another number I can factor out? Because 5 and 320 are not perfect cubes. So let's see if I can factor out a 5. 320 divided by 5 is 64. Is 64 a perfect cube? 64 is a perfect cube. So let's factor out a 5. 5 divided by 5 is 1, and I already have a k. 320 divided by 5 is 64. Now I already have 1k. I need a total of 4. So I need 3 more to get a total of 4. Now on this inside portion, let's show the work. 1 breaks into 1, 1, 1. 64 breaks into 4s. And when I divide this number by 3, it is divisible by 3, it breaks into 1s. So completely forget about the 5k up front until the end. Okay, this is always going to be addition. I start with the given operation and then I change it. Taking 1 from the front, taking 1 item from the back, and then I cancel those out. 1 times 1 is 1. In the back, 4 times 4 is 16, and there's 2 k's. How do I get this term? Bless you. I multiply. 1 times 4 is 4, and attach a k. So again, sum or difference of cubes. When you don't see a number up front, it's a 1. Now, 1 is a perfect cube. 1 breaks into 1, 1 and 1. 27 is a perfect cube. 27 breaks into 3, 3 and 3. In order for us to keep going, the exponents on the variables have to be divisible by 3. That means when you divide them by 3, you get a nice whole number. 6 divided by 3 gives you 2. This breaks into r squared. Is 15 divisible by 3? When you divide it by 3, you need to get a whole number, which is 5. S to the 5th, S to the 5th, S to the 5th. That's not 5 to the 5th. Those are ugly S's. Okay? 2 in the first part, and there's 3 in the second. We have subtraction for this problem and opposite. So from the front, I'm going to take a 1r squared. From the back, I'm going to take a 3s to the 5th. Now, this is where it gets tricky. This is all based on your algebra teacher's understanding. So if they explain this well to you and you remember the concepts, then moving forward, this is going to make sense. Are you ready? Everybody should know right now this is the front. So how do I get the front? 1 times 1 is 1. Here's the tricky part. There's not 2 r's. When you add their exponents, how many r's are there? 4. That's the tricky part. Now in back, 3 times 3 is 9, but there's not 2 s's. How many s's are there? 10. And then the middle part here, we just multiply. 3 times 1 is 3. R's and s's aren't the same, so there's 2 r's and 5 s's.